Here's a nice animation environment provided by our textbook publisher, and it shows thermal circulation. Right now we have two identical cities that have the same surface pressure and the same thickness of air above them. Let's say that the surface pressure is 1,000 millibars for each one, and the top of this column here is 900 millibars. That's balancing out that pressure, upward pressure of 900 millibars of pressure is balancing out the weight of the air above that's pushing down in both cases. Now what we're going to do when we press play is we're going to warm this city up and cool this city down. Let's see what happens. Okay, as we do that, the city on the right expands due to the gas law, and the city on the left contracts, shrinks down. What that means is that since the top is still 900 millibars of both columns, the same amount of air, the air pressure in the warm column drops more gradually. It drops from 1,000 millibars to 900 millibars over a much greater distance than the air pressure in the cold column. It drops from 1,000 to 900 millibars over this short distance. And so at this vertical level, the air pressure in the warm column is somewhere between 900 and 1,000, maybe 940 millibars. And over here, it's very close to the 900 millibars. So that means the air pressure here is relatively high compared to here. That causes air to flow from the warm column over to the cold column. This column loses air, which would result in a lower surface pressure, and this column gains air, which would result in a higher surface pressure. Once this high pressure and low pressure near the surface is established, air flows naturally from the high pressure to the low pressure again. Okay. One thing that isn't showing on this picture, there are a couple things. One is that the air in this column will rise up, move over, and then sink down. This is a classic thermal circulation. Warm air rises is the way I like to think of it, and then we can complete the loop on around. The other thing is, in this warm column, the rising air typically gives rise to clouds. So it'd be nice to see some fluffy clouds over here. And the cold sinking air in this column typically gives rise to very clear skies, and so a sunshine over here would be nice.